All right, I'm going to go through experiment 16 report sheet where we're doing the oxidation reduction titration of the dichromate with the iron oxide. All right, so in number one, it asks for your mass, so that's just a data point. So whatever mass that you weighed out, in this case it was 0.5454 grams of your dichromate, and everybody should be in 100 mils of solution. We put it in a volumetric flask. All right, and so then it asks for the molarity. So you take your 0.5454 grams, divide by the molar mass to give you moles, and then you convert your 100 mils to liters. That's 0.1 liter. All right, so in this example, the molarity was 0.01854. All right, number three is just data. How much iron oxide did you weigh out? In this case, 0.1986, 0.2160, and 0.2161. All right, so then you have your titration, final minus initial. And in this case, we required 20.35 to reach the end point. In the second one, it was 20.48 to reach the end point. And in the third one, 20.39 to reach the end point. All right, so then it asks for the mass of the iron. So now we're doing the titration. In order to do the titration, you have your MV over C is equal to MV over C, or in the case where we want mass, it is the mass divided by the molar mass over C. So you have to get the coefficient. So before we can do this, we have to balance our oxidation reduction reaction. All right, and so you can look on table 19.1. This one is worked out for you, or you can do it like we do in class. Get your oxidation numbers for chromium. On the left is +6. On the right is +3. All right, but it is a dichromate. Cr2O7 is a dichromate. So that means that we have to gain 3 electrons per chromium, but we have 2 chromiums. And so we are gaining 6 electrons. Our iron +2 is going to iron +3. So we are losing 1 electron for every iron. All right, but if we have gained 6 electrons, now we need to lose 6 electrons. And so that's why we multiply our irons by 6. So when we multiply it by 6, we get 6 electrons lost to equal our 6 electrons gained. All right, to complete the balance, you get your charge. So you find your total charge on the left. You got a -2 and a +12. Total on the left is a +10. On the right, you've got a +6 and you got a +18. You got a +24 on the right. So to make those equal, you need 14 H pluses. And so now you have 24 and 24. To balance your H's, you need 7 waters. All right, so you have your balanced reaction. So what we needed to get from this balanced reaction is the coefficients. And so when we take our dichromate, we have our molarity that we solved in number 2. That was the 0.01854. The volume, we have that in number 4, but we have to convert that into liters. So that is a 0.0235 liters. And now we see our coefficient in our balanced chemical reaction for our dichromate is a 1. And so we have that divided by 1. All right, and so on the other side, we're looking at our iron +2. So we want the mass of the iron +2. All right, and so we have our coefficient. We now have it as 6. The molar mass of your iron from the periodic table is 55.845. And then we solve for the mass. All right, and so when you do that, you get a 0.1264. When you do the next one, all you're doing each one of these times is changing your volume. So you have a different volume. And so you have a different mass. You have a different volume. You have a different mass. Everything else is the same. Same molarity of EDTA, the same balanced reaction, the same molar mass of iron. All right, so now we have our mass of iron. And in number 6, it says calculate the mass %. So you take your mass of iron divided by the mass of your unknown iron oxide sample times 100. So in this case, it was 63.65. In this case, it was 58.89. In this case, it was 58.63. All right, so to get the average in number 7, you simply add them up, divide by 3, and you get 60.39%. All right, number 8, as for the standard deviation, you take run 1 minus your average, square it, plus run 2 minus your average, square it, run 3 minus your average, square it, and then you divide that by n minus 1, where n is the number of times you did it. We did this 3 times, minus 1. And then you take the square root of that, and you get the answer of 3. So when your standard deviation is 3, that means that you're going to round your 60.39 to the ones place. And so you get 60 plus or minus 3%. And now we have our calculations at the bottom. How many grams of potassium dichromate are needed to make 500 mils of a solution? And we want to have a 0.03022 molar. So that is your moles per liter times your 0.5 liters. Multiply that by the molar mass, and that will give you your grams. On number 2, you can balance this reaction by looking at table 19.1. All right, so there it is, but it's also on table 19.1. Part B is a question I need to omit. The molarity is the same. Does not change no matter what you're titrating. If you're using that molarity, that's the molarity it is. All right, and then C, reducing agent, that is the reactant of your oxidation half reaction. Your oxidizing agent is the reactant of your reduction half reaction. All right, then in D, to find delta G, you got to find your E values from table 19.1. So I wrote them down right off the table. I had to reverse the 10, that was the oxidation half reaction. And so I changed the sign to a negative 0.15. I also multiplied through by 3, so that 6 electrons gained equals the 6 electrons lost. And so when you add up your two E values, 1.33 and negative 0.15, you get 1.18 volts. And to get the delta G, that's simply negative NFE. So the moles gained and lost was 6. F is Faraday's constant, and you're 1.18, and you get a negative 6.83 times 10 to the 5th joules. And since that is negative and E is positive, this reaction is spontaneous. That is how you fill out report sheet experiment 16.